Handwritten notes for the following lectures are given in the description box. These are in the exam point of view. Lines from K. Tripathi are simplified and given for you to write in your exams.
Today's topic is first order and zero order kinetics. This is from Doxyverse. Okay, now let's get into the topic. Before getting into the actual topic, we should learn the term clearance. Okay, what is clearance? Clearance is a theoretical volume of the, learn the definition, I'll explain it later, okay? First hear the definition. Theoretical volume of the plasma which is from which the drug is completely removed. Per unit time, okay? Per unit time. Suppose if I'm considering this unit time as 1 hour, I'm calculating how much drug, how much volume of the plasma is cleared from the drug, okay? That is known as clearance, okay? How much volume of the plasma for a particular time, for a fixed time. I'm fixing the time as 1 hour. I'm calculating the clearance for 1 hour. If I'm calculating the clearance for 1 hour, I should check how much volume of the plasma is actually cleared from the drug. It is known as clearance, okay? First learn this, and here is a formula to calculate the clearance. Actual clearance formula is clearance is equal to R rate of elimination of drug, RED, by concentration of the drug. Okay, now there may be a doubt for you, what is rate of elimination of drug? Now understand this. Rate of elimination of drug is like, see, the rate of elimination of drug is mg per hour. Can you tell the definition with this unit? This is amount of drug removed per hour, that is per unit time. If suppose 500 mg is administered and 50 milligram is removed, this is 50 milligram is removed from the body. How much gram is removed from the body? That is how much plasma is free of drug, how many plasma is get cleared from the drug. It is known as clearance. Clearance is different, and rate of elimination is different. Don't confuse both of them. If you're getting confused with the definitions, please remember the unit. The unit of rate of clearance, rate of elimination is mg per hour, that is amount of drug eliminated from the body per hour, okay? This is known as rate of elimination. On concentration of the drug, already you know how much concentration is present in the blood is known as concentration of the drug. Okay, now we'll get into the actual topic. First, what we should learn? First, we should learn about the first order. Students, I know it is a very hectic topic for you to understand, so I'm making it so simple to make you understand very easily. So please listen to the lecture carefully. So don't skip the lecture, don't skip this part. It will be very useful for you in the upcoming lectures, upcoming topics. Okay. Now let's get into the actual topic, first order reaction. What we should remember when it comes to the first order reaction. Here, rate of elimination is directly proportional to the plasma concentration or drug concentration. Both are same because how much concentration we administer will get into the plasma, okay? Okay. Now, what happens here? You should remember the basic formula. Don't just mug this, okay? Just remember the basic formula. Rate of elimination is equal to, here we have learned the formula, right? Bring the concentration to the left hand side, so that concentration into the clearance, okay? This is the formula. This is plasma concentration, and the actual formula is there will be a power x. This x denotes the order of the reaction. Now, about what reaction we are discussing? We are discussing about the first order reaction. So, RE is anything per 1 is same, okay? Plasma concentration per 1 is actual plasma concentration. No need to change anything, okay? So, plasma concentration comes in. And clearance. Where does the clearance went? Why does the clearance is kept constant here? How did we derive this statement? I'll explain that, okay? This statement, with this statement, we should remember that for a constant dose, or a drug given, at the time I can give only 5 milligram, okay? I can't increase milligram, okay? At a given time, I can give only 5 milligram. At the same time, can I give 10 milligram, 20 milligram of a particular drug? No. So when the concentration of the drug is constant, the clearance is constant. So clearance gets constant. If the clearance is constant, how does the formula change? We all know. Rate of elimination is directly proportional to the plasma concentration. You understand from where we get the statement? Where do we say the statement? You understand? Okay. Constant, here, the thing we should remember is, a constant fraction of, here not amount, a constant fraction of drug is removed. Constant fraction or proportion of the drug is eliminated. Okay, what is meant? What do you understand from this statement? What do they say? I will explain with an example. For example, if you take 50 milligram of the drug, as I already said, the constant proportion is eliminated per hour. Okay, per unit time, per hour. Unit time means we can fix both hour and minute in that case. Okay, if you're checking for a minute, it is then unit time will be minute. If you're checking for hour, the unit time will be hour. Okay, now 50 milligram, the 50 milligram, let us keep only 20% of the 50 milligram is eliminated per hour. Okay, now what is the 20% of the 50? 20 by 100 into 50 by 2, 10. Okay, only 10 milligram is eliminated. Now the drug in the plasma concentration decreases, right? 10 is eliminated. Initially there was 50 milligrams. After the elimination, after 1 hour, the plasma concentration becomes 40. As I already said, the elimination is directly proportional to the plasma concentration. If the plasma concentration decreases, rate of elimination also decreases. See, here 10 milligram is eliminated. But what is constant? Yes, the constant, the proportion or the fraction of drug eliminated per hour is constant. See, again 20% will be eliminated. From 40, 20% into 20. What happens? See, then 8. Here 8 milligrams is eliminated. So again 32. You understood? What does this statement says? What is the meaning of this actual meaning of the statement? This is the actual meaning of the statement. A constant proportion, only a constant proportion. Say if 20% is eliminated, the same 20% will be eliminated after every hour, but not the amount of drug. Amount of drug differs. See, at the first hour, 10 milligram of the drug is eliminated. At the second hour, 8 milligram of the drug is eliminated. So here, as we can see, the rate of elimination is directly proportional to the plasma concentration. See, initially plasma concentration was 50. After the elimination, after the first hour, the plasma concentration decreased to the 40 milligrams. And the plasma concentration is 40 milligrams. The plasma concentration decreased, so rate of elimination also decreased. Here, what is the rate of elimination? As I said, milligrams per hour. So 10 milligrams per 1 hour. Here the rate of elimination is 8 milligrams per hour. See, rate also decreasing. As the plasma concentration decreases, rate of the elimination also decreases. This is what the actual meaning of first order reaction. Understood? Do I made it clear? Okay. And examples, most of the drug follows first order reaction, so we don't need to study any particular example for this. I'll say all examples for zero order reaction. Excluding that, all of the drugs follows the first order reaction. Okay. Next, we'll enter into the zero order. Bring the same formula. Say the definition on your own. Rate of elimination is equal to plasma concentration over the order into clearance. As I said, for a fixed dose, clearance is, what happens to the clearance? Clearance is constant. So RE is constant into plasma concentration over, what is the order? The order is zero order. So anything per 0 is 1. So here the rate of elimination is constant, is equal to constant. It never changes. What do they mean? What do they mean? I will again explain this with an example. Don't worry. What do they mean is, if suppose again 500 milligram I'm taking. Let's rate of elimination is constant. That is, a milligram eliminated per hour is constant. Then 20 milligram eliminated per hour regularly. So at the first time, what happens? 40, 480. Again 20 will be eliminated. So it will be 460. Again 20 will be eliminated. It will be 440. See, even the plasma concentration decrease. Initially the plasma concentration was 500. Now the plasma concentration is 480. Now the plasma concentration is 680. But the rate of elimination, what happens to the rate of elimination? Here 20 milligram per hour is eliminated. Here also the 20 milligram per hour is eliminated. Here also 20 milligram per hour is eliminated. So more likely we can define the as a zero order reaction like amount of drug eliminated per hour is constant. Understand? Understood the concept? Okay, this is the concept. Okay, here I will say a few examples for you to make it easy. In zero order kinetics, examples are phenytoin, talbutamol, theophylline, warfarin. Okay, now we have for a fixed dose, clearance is constant, right? What happens when we increases the dose? What happens when we increases the dose? You understand my question? If we increases the dose, what happens to the clearance in first order, in zero order? Okay, let's discuss that. Now, what happens to if we increase the dose in first order reaction, the clearance decreases. Sorry, clearance is constant in first order reaction. Even if we increases the doses, the first order reaction clearance is constant, but in zero order reaction clearance decreases. Okay, think, why do the clearances decreases? Why the clearances decrease? Because What happens in the first order reaction? In zero order reaction, rate of elimination is constant. It is constant because what is constant? Clearance is constant. If clearance is not constant, it is proportional to the clearance, and when the dose is increased, clearance is decreased. Okay, understood? When the dose is increased, clearance is decreased. Similarly, in the first order reaction, what happens? Why the clearance is constant? Anyways, whatever thing has happened, RE is directly proportional to plasma concentration. When RE by PC is clearance. So if the RE increases, plasma concentration increases, RE increases, so it gets compensated and there is no change in clearance. So clearance is constant for the first order reaction. Okay, what happens to the half time? Check what happens to the half time. See, if I'm taking 100 milligram, okay, a rate of elimination is 20% in the first order reaction. So what is the 20% of 100? It's 20. So 20 is eliminated. So now 80. What is the rate of elimination for 80? It's 16. Okay. So what is 80 minus 16? It's 64, right? Similarly, 64 into 20 by 100. It's nearly 34, 64 by 5. It's nearly 12 or something, I think so. It's nearly 50. Okay. Nearly. So how many half times it took? 1. That is 1 hour, first hour, the second hour, third hour. It took 3 hours to attain the half of the initial concentration. If you don't know what is half time is the time taken by the body to attain the half of the initial concentration. Here it took 3 hours. Okay. Now I'm increasing the dose. 20 mg. 200 mg. Now what happens? 200 by 20 into 200 by 100. It's 40. So 40 is eliminated. 160 is eliminated. 160 into 20 by 100. It's how much? 32. So 32 is eliminated. 160 minus 32 is 30. 128. Okay. Another time it comes nearly 100. Okay. If you want to calculate, please calculate and check. I don't want to extend the time. Then again, check the hours. First hour, second hour, third. What happens to the half time? See, again it took 3 hours to attain the half of the initial concentration. So the half time of the first order kinetics remains constant. Whereas we'll check for the second order, zero order kinetics. Check 100 milligrams, 200 milligrams. A fixed amount is reduced, eliminated. So 200 is eliminated, 20 is eliminated, 80, 60, and a half. See, 1 hour, and in a half an hour it will get into 50. Okay, again check 180, 160, 140, 120, and 100. Here, first hour, second hour, and half hour. 2.5 hours is took the drug to attain its half of the concentration. Here, 1, 2, 3, 4, 5 hours. Nearly 5 hours it took to attain its half of the initial concentration. So the half time of the zero order kinetics increases. Okay, so you understood the whole concept in the zero order and first order reaction. No confusions. I hope no confusions is there for you. Okay, now I'll ask you a question. Where do they come? Where do we want to apply the zero order and first order application? Where do we use these? What do they mean actually? And see, zero order kinetics is for yearly saturation of elimination. Why do the drug follows these kind of orders? What do they actually mean? What do they actually come to say to us? Is first order reaction follows late saturation of elimination. Okay, think. What is that yearly saturation, late saturation? Think. Here, 50 milligrams per minute of the drug is eliminated. Just imagine. 50 mg is eliminated per hour. Okay. When I give 20 milligram, how much milligram is eliminated per hour? 20 will be eliminated. See, saturation level is 50 milligram per hour for a particular drug. When I give 30 milligram, how much milligram is eliminated? 30 will be eliminated. Okay. When I give 40 milligram, how much milligram will be eliminated per hour? Obviously, it's 40 only, not more than that or less than that. But when I give 50, 50 is eliminated. But when I give 60, again 50 only, because it crosses its saturation level. Only 50 is eliminated. Remaining 10 will come in another hour only. Okay. So it doesn't come into the calculation. It doesn't take it into account. Okay. 70 is given, 50 only. So see, what is the now check the rules. Now check the rule. Rate of elimination is directly proportional to the plasma concentration. See, plasma concentration is 20, rate of elimination is 20, plasma concentration is 30, rate of elimination is 30, plasma concentration is 40, rate of elimination is 40. As the plasma concentration increases, rate of elimination is also increasing up to saturation level. But when it crosses the saturation level, see, plasma concentration is 60, but the rate of elimination is 50. Plasma concentration is 70, rate of elimination is 50. Why do we see the rate of elimination is constant? Rate of elimination is constant in zero order reaction. So when the drug reaches the saturation level, the drug follows the first order reaction. When the drug crosses the saturation level, it follows the zero order reaction. So the drug which saturates earlier, suppose only a threshold level is 2 milligram per ml. Even if no drug can be taken within this limit, it should be more than that. Okay, if this threshold level is very less, it always follows the zero order reaction. If the threshold level is more, it follows the first order reaction until it attains the saturation level. Understood? Are you clear with the concept? Go back, read your textbook. It will be very, very easy for you to understand all lines. Okay, I have explained each and every lines in the book. Each and every lines in the book. So don't get confused with hereafter. Don't get confused with the first order and zero order kinetics. You have learned a huge concept, students. And we have provided notes in the description. Please check that. It will be easy for you to prepare a day before in the exam, so that every word in the KT Tirupati has been given has been simplified in the notes. So please check that, and thank you.